Hello, everyone. My name is Vishal Manan, and I'm a senior Graviton specialist, SA in WWSO in AWS. And today I'm going to be talking about Porting Advisor for Graviton, which is a new tool to help you with your porting efforts to ARM64. So we're going to talk a little bit and give you a high-level overview of the tool. The tool actually is available on GitHub. It's freely downloadable. It's not an AWS service. And the tool actually scans source code files for the languages that it supports currently. And it would skip the files for languages the tool doesn't support currently. And we'll come to that a little later. It'll also scan the dependency files, build files for the languages that are supported. The tool doesn't make any code modifications. It's not a tool to actually do the port. It just helps you identify issues in your code, which could be challenging. And this really makes sense when you have large code bases. And for whatever reasons, people may not remember how much of code was in there, which is specific to an architecture like x86. So in those cases, it comes in handy. It does not provide any API level recommendations. And more importantly, it doesn't send any data back to AWS. Now, you can use this tool as a Python script or compile it into a binary and run it on either x86 systems or ARM64. So you have the flexibility of picking the tool to run in any environment that you would like. And keep in mind, the idea behind either running it as a script or as a binary is totally your choice. And a few factors may help you decide that. If you use it as a binary, then you don't have to install all the Python requirements. And also this could become part of your build system if you want, maybe as part of your quality gates to look for things that may have got added once your port is complete. And just for your CI/CD pipeline, it could be just another check in there. So the current supported languages are C, C++, Fortran, Golang 1.11 onwards, Java 8 onwards, and Python 3 onwards. And we do realize there are many more languages that you may want, that you may have written your code in. And if there are languages that are not supported and you have a need for that, you can definitely put that as a requirement in the GitHub page. And I'll come to that a little later. So the high-level working of the tool, the Porting Advisor for Graviton, is pretty straightforward. I mean, you can see it's a very simple to use tool. As I mentioned, the tool can be run as a script or a binary. All it needs is Python 3.10 installed on the host. What is the host? Host is the system where you're going to be running this tool. It could be your build system. So in my case, I'm going to be doing my demos on my PC. And also I'll do a demo on an EC2 instance, which is running on Graviton. You could use this tool on a Mac. So any place you can basically run Python on. Now, if you have Java code and you have jar files in there, and maybe there's dependency, you have native code, JNI code in there. In those cases, you would need to install Java 8+. But if you don't have Java code, you don't need to install anything. So once you have your environment set up, then you would run the tool and you would provide it as an option whether to generate a CSV file or an HTML output. So if you don't do that, it just spits up output on the terminal. Okay. So as you can see, it's a pretty simple tool to use. Now, who can run this tool? What's the skill set required? Um, it's as I mentioned, it doesn't require a whole lot of understanding of of programming. Anybody who has an understanding of the build system, project requirements, dependencies, versioning, etc., has a background maybe in some scripting languages like Python, PowerShell. And in case your code has C or C++, or maybe Fortran, then you may need to have a better understanding of things which may be in your code, like inline assembly or intrinsics. So it may depend pretty much on your source code. So C++ would require a little more understanding, especially to understand the errors which come out from the report or the issues that it detects. So what kind of issues are detected by the tool? Firstly, the tool will scan your source code files. And if you notice, a lot of the issues that I'm talking about here will be actually specific to C and C++. And I'm going to talk about where the language is different from C, C++. I'm going to mention it. But for most of the other points, it's going to be relevant to C, C++. So if you have inline assembly, maybe for performance reasons in your code, but obviously that's meant for x86, then it'll flag it that you may need to have similar assembly code for ARM64. Same thing for things like preprocessor flags, where you have x86 specific flags, but then it tries to see if there is anything specific for ARM. If not, it'll flag it. If you're using old Visual C++ runtime, then it may actually let you know about that. So the tool is, if you have less tech debt, if you have been using more modern tool chains, and also your code base is kept up with tool chain evolution, in that case, you actually may have fewer things to worry about. And also keep in mind that the tool is not meant to find every single problem in your source code. That would be just too difficult. For example, it will also find issues against linking against libraries that are unavailable for ARM64, for example. It could also find things, and it's very difficult to keep track of all the libraries out there. There are like thousands of libraries out there. So it's just very difficult to make sure that every single library is covered. But the more general purpose libraries that we have come across are all mentioned in the tool. It'll actually look for those for support for ARM64. So please keep in mind that it's not going to exhaustively find all the issues in your code. And it's meant to be a guiding tool to help you identify issues and then go from there. So what the tool doesn't report, so if you have compiler-specific code guarded by compiler-specific predefined macros, it's not reported by default. I think that should be a given. So issues like cross-compiling. So if you're if you're compiling for multiple architectures at the same time, then it will detect the architecture on the host rather than the target, which is what you would probably want. So in those cases, obviously, it's not going to report that. Okay. So I'm just giving an example here of how do we actually keep track of packages. So in this case, Python is a very commonly used language, and I'm going to show you that we have actually more than 200 plus Python packages that we track for compatibility with ARM64. So let me just give you an example here. So this is for today. May 15, 2023. By the way, this is all publicly available. And you can see that we have Amazon Linux 2, Amazon Linux 2023, and majority of the packages actually are passing. And we have some packages which don't, and there's probably reasons for that. So there's around, I think, 231 wheels which are covered here. So just give you an idea of how we are tracking Python libraries and Python packages, and we would actually be adding more as time goes on. Okay, so let me get back. And another thing is that if you're using Python code, the Graviton technical guide, which has a URL mentioned here, has a lot of good information for a variety of languages that are used. And it's a subset of, it's a superset of all the languages that this tool supports. So there you would actually be able to find out way more languages, C, C++, we have .NET, there's Golang, Java, and Python, Rust. So you can find specific information for the language that you're using in the Graviton technical guide. So Java is a very commonly used language. And so if you think about Java, which is a language which compiles to bytecode, and then it has JVM to actually run to native. This has the benefit that if the JVM itself is updated to the newer version, then ARM64 support and even performant ARM64 support is available to you. So if you are planning to use Java 8 is the minimum requirement which supports ARM64. But for performance benefits, we recommend using Java 11. And Amazon Corretto JDK is the fastest way to get all the performance benefits. So we recommend that. And that's also mentioned, all of this is mentioned in the Graviton technical guide that I was referring to earlier. Okay. So one quick overview of building and deploying. This is not meant to be exhaustive, but I'm just giving you an example of things like native compilation versus emulated compilation. So obviously for performance reasons, it's better to compile to native whenever possible. And Docker uses QEMU emulation. And that will be slower. So when you use, especially when you're compiling for multi-architecture, you will see a little bit of a performance degradation there. And for a developer, I think that should be okay. But for your build system, you'll have to think about that. So now let me switch gears and give you a demo of the tool. I think that's the interesting part for a large majority of people. So I'm just going to give you an idea of what the demo is going to cover. So this is the output of what you're going to see in the demo. So it talks about the inline assembly is the folder where I have my code, which is what I pointed it to. And then it has flagged issues in a file and the line number, and in some cases it'll also give you the function. So the tool is pretty good at actually giving exact pinpointing its exact location of the issue it has found. It's not going to give you guidance on how to fix it, at least not yet, maybe sometime in the future. But I think this tool is a good start to start looking at your code bases when you think about moving to ARM64 architecture. So let's look at a few different things that I'm going to be demoing today. I'm going to talk about building the tool, And that's only going to be necessary if you plan to build a binary. If you're not planning to build a binary, then you don't have to build it, obviously. Building it into a binary would actually give you the benefit of being able to run it on any system without having to download all the Python packages. And it can also integrate well with your build system. So that's the first part. Then I'm going to talk about running the tool as a binary and script on both where you can run this, that is on a PC or EC2 instance, and the Mac is also supported, so you can run it on a Mac as well. And then we're going to look at a few different use cases. So there's going to be use cases around C, C++. I think that's where the tool really shines in C, C++, especially large source codes, which is based on C, C++. I think that's where you'll see the maximum return on investment. We're going to talk about inline assembly files, intrinsics, and then I'm going to showcase how fast the tool can run on a large C++ project. Finally, I'll also demo a large Java project which has jar files in it. So let me point you to how you would actually get started with using the tool. So you'd go to the GitHub page, and the GitHub page, you're going to find a script called, this is build.ps1, which is for PowerShell. So if you're planning to use Windows to build, I'm just going to take that as an example. You're going to find that. This is a GitHub page, and you're going to find all the scripts that the tool uses to build. And the one which I was referring to is this one here, because I'm planning to use Windows as an example. So you look at this script, it's pretty straightforward. It has a way of changing the name of the binary if you want. Otherwise, you can just leave it as default. I'll check for Java. In case you have Java code base, then I recommend installing Java. And then finally, it actually uses PyInstaller to build the binary. And so you need to install that prior to actually building the binary. So it's as simple as that. I don't think it can get simpler. And in the interest of saving time, I've actually already built the binary. And you'd find that. So I'm actually using the binary to compile. So if you see, what's going to happen is it's going to generate the binary in the distributable folder. And if you go there, you're going to find the path to the binary. And then you will see. And I kept the name as is. Obviously, you can change it. So I'm going to be using, for my demos, the binary as well as the Python script because they're identical in their functionality. And it's just to make sure that you understand that you could use either method to get it to work. So getting back to the first demo. So right now I'm going to show this on the PC, and I'm going to use maybe the binary to look at inline assembly files. So I'm going to point it to where I have my inline assembly. I'm going to give it the folder. So the way to run this tool is either the script or the binary followed by the folder, which points to your source code. And then you can have as an output an HTML file or a CSV file. So for this example, let's just take inline assembly.html. And since there's not many files in there, it's pretty fast. So let's look at the output. And I have the output here. And so if you notice, it's found that there is inline architecture-specific inline assembly. And if we go and look at those files, this is the code I had there. So it's got assembly code for x86, and that's why it flagged it. So as you can see, that's the assembly.s file, which has the assembly code. Now, let's take another example. Let's say we're going to look at intrinsics now. And this time I'm going to keep the output as CSV file. So call it CSV. And if I go and look at the CSV, so it's pointed me, let me expand there. It's going to give me the file name where it found the problem, the function name, the line number, and the issue. So I think it's pretty handy in actually being able to let you know very specifically where you may have issues in your source code. And let's look at that file at line 84. So I already have it open here, and that's the one it's complaining about. So this bswap 64 is intrinsic for x86, and that's what it's flagged. So when you want to port this code, you'll have to find an equivalent for ARM, or have to figure another way of actually making sure that either you point it to another function. Intrinsics do have their benefit, especially with performance. So that's the reason they are commonly used. But yeah, so that's something would be the next step for you, is to actually find an equivalent for ARM64, or find another method of using that function. Okay, now let's go back and talk about a few other things. So I showcased right now everything on a PC. You're running as a binary, and I'm going to showcase the script version a little later. But I'm going to now switch to an EC2 instance, which is running Amazon Linux 2. So let's see. This is to you. This is just an EC2 instance which has only one CPU. So it's pretty straightforward, nothing fancy, and it's running Linux. So it's running Amazon Linux 2 in this case. And let's go ahead and on this, on my EC2 instance, I already have compiled the tool into a Linux binary. So we are in the dist folder. So that's where it is. It's the Porting Advisor Linux 8 ARC64. You can rename it. And we're going to run this and give it an output. So here I'm trying to showcase that I'm going to be running this tool on fairly big size C++ project. I think it's the code for the .NET Core, which is available on GitHub. So it's fairly big, and I'm going to start that. And while it's doing that, I'm going to actually showcase, because I already have done this earlier. So in the interest of time, I'm going to showcase what the tool would find. Okay, so this is the output of the tool. Since it's already compiling, and in the interest of time, I'm going to just showcase what the output is. It's going to take around maybe around 2 minutes or so, running on one processor and looking at maybe 4,000 files or so. So not too bad. So the output here, which is looking at the core CLR code from GitHub, it's found quite a few different things, preprocessor issues, So if we look at that file, so let's try and open that file, and let's go look at the line number. It was 8538. As you can see, it spotted that is an x86 AMD 64 defined preprocessor macro, and it's flagged that. So you want to make sure that there's ARM64 also in there if needed. The tool is not smart to know exactly whether it's something specific to x86 and the other architectures don't need to do in some cases, or something that all architectures need to have in the source code. So this is an example of how the tool actually functions. And let's see if my build, if the tool is completed. Let's see, it's, yeah. So it finished fairly fast, I think 2 minutes and 19 seconds. So pretty snappy with single proc running on Amazon Linux 2 and on ARM64 in this case. And it scanned around 4,000 files. Yeah. So just want to showcase that tool is pretty fast, doesn't need a lot of CPU resources. So it should be pretty snappy. Okay, now let's move. So far I've showcased you a few different things. We've run the tool on PC, run the tool on EC2 instance. We have looked at the output, multiple kinds of output the tool can actually show. We haven't run the tool as a script yet, so I'm going to showcase that, and also with Java. So let's do that. Okay, now let's try and run this tool as a script. So very similar to what we've done earlier as a binary, just install, invoke the Python script putting advisor.py, which is what you would get from GitHub. And then you just point to that folder and then give it as an argument the location of your source code, and then the output, which is in my case java.html. So I've launched this, and while it's going to scan through, this is a source code for Apache Spark on GitHub. So it's a fairly large size source code. If we actually look at how many files are involved here, yeah, so that's going to be around so it's got around 20,000 files there. So fairly large code. And while it's doing its thing, let's go and look at the output, which I had pre-generated. So the tool is completed running. This is on my x86 system. So I just want to showcase that you can run it. It doesn't have to be ARM64 for the host. It went through 20,000 files in 1 minute. And obviously, it skipped the files for any languages which were there, which is not supported currently, and also the build scripts. So let's look at the output. Okay, so hopefully that should be visible. So in our case, out of those 20,000, only 1,764 files actually were something that the tool could scan. Maybe the rest were all languages that the tool doesn't support, or other build/dependency files, which were not important or not used by the tool. So in our case, what we notice is the tool will go through the pom.xml file, and then it'll see that, hey, what are their dependencies, and if they're supported on ARM64. In this case, there's the level DB GNI, that's the native code. All is not supported. So for this to run on Java code, you need to have Java installed. So in my case, I have Java version 17 installed, and that's the Corretto. And I have a link for that. I'm going to share that, but it should be available through the Getting Started or the Graviton Technical Guide. So I pointed to that earlier. A lot of all of this is already mentioned there. So far what we saw is how to build the tool. We saw how you can run it as a binary and as a script on PC with x86 or an EC2 instance. And then we saw a few different use cases across C, C++, and Java. And so it's a tool that I think is fairly straightforward to use. It's pretty snappy. You don't need a lot of processing power, and you can run it from your developer machine with no issues. So I think you probably saw from the demo that the tool is pretty easy to use. You don't need a whole lot of resources to run the tool. You can run it on a dev machine. And then I just want to leave you with a few final words. This tool is going to really help in case you have large code bases, especially if you're using C, C++, where I think the tool would shine. It'll point to things that you could miss. It gives you a fairly accurate indication of the file, the line number, and the function. And I think that comes in pretty handy. It makes you make sure that you're not missing anything. Obviously, when you compile, you will find out. So it's not that's something that you're going to miss out. But I think it's going to be useful to actually, especially for a lot of the AWS customers. So the tool is going to help you in case ARM64 architecture is new to you. And it's just the fear of the unknown, right? On what problems you may run into. So in those cases, the tool will show you sort of where challenges lie in your source code, and maybe make you feel a little warm and fuzzy on moving to ARM64. So I will leave you with those parting words that definitely give it a try. It's straightforward, easy to use, pretty snappy, and then I think it'll give you a sense of what your effort might be when you move to ARM. It's not going to find every single issue, as I mentioned earlier, but it's going to do probably a fairly decent job in finding a large majority of things that you could run into. If there's tech debt, you have older versions of packages that you depend on, this may be time to move and make those updates. So I think we'll leave you with that. There are a few links I have here. The first link points to basically filing bug or feature requests that you may want from the tool. And so there is a link to the GitHub page, which you can use to do that. There is the link to my blog, which I mentioned earlier, in case you want to see a step-by-step version of doing this. And then I have a link to the Coding Advisor GitHub page. Also, if you have maybe C, C++ code and you're using SIMD, then there are a few interesting intrinsic options available, and this is from ARM. So you can check those two links out in case you're using specific intrinsics for x86 for SIMD. Okay, with that, I want to say thank you. Good luck with your porting, and have fun. Thanks.